Hello, I'm Edward Tarte, math teacher. This is one in a series of solution videos to some of my math challenge videos. This particular one is my Please Be Seated challenge, and here's what I said in that challenge video.
Suppose we have 12 empty seats, 12 empty chairs lined up in a row, numbered 1 through 12 consecutively. We also have 12 people numbered 1 through 12. These 12 people are going to sit in these 12 chairs. They will be seated one at a time, each person sitting in his or her numbered chair. For example, person number 8 will sit in chair number 8. They will be seated one at a time until all 12 chairs are filled, and in such a way that after the first person is seated, each person after that will sit next to somebody. For example, if the first person is person number 8, the next person will have to be either number 7 or number 9. Again, they will continue this process sitting one at a time until all 12 chairs are filled. And the question is, in how many different orders can this be done?
Well, this problem is based on numbers of alternatives, numbers of choices. It is the same basis as in this very simple example of flipping a coin, say, 3 times. You flip it the first time, it could come up either heads or tails. That's 2 alternatives. You flip it a second time, for that you also have 2 alternatives. You flip it a third time, 2 alternatives for that also. You get the total number of possible sequences by multiplying 2 times 2 times 2, which we call 2 to the third power. That gives 8 possible sequences. The same principle should apply to this problem. So the first person to sit down, that's 12 choices, 12 alternatives. But after that, things get sticky. If that person, for example, is number 8, then following that, in the next seating, there are 2 choices, either number 7 or number 9. And there may continue to be 2 choices for quite some time. But once a person on the very end of the chair sequence, either chair number 1 or chair number 12, is seated, thereafter there's only 1 alternative each time. So, for example, if the first person to sit is number 11, then there are 2 choices after that, 10 or 12. If the next person is number 10, there are still 2 choices. But if the next person is number 12, thereafter, until the end, there's only 1 choice. So this is very frustrating. How could a potential solver possibly keep track of all the possible choices? In order to be successful in this problem, it is expedient to think outside the box. And here's a key idea to make the problem easier. The number of ways of filling the chairs, that is, going from empty to full, must be the same as the number of ways of doing the exact opposite, of emptying the chairs, going from full to empty. Because for each way of filling the chairs, there is a corresponding way of doing the same thing backwards, emptying the chairs. And so let us think of the number of ways of emptying the chairs. It is much easier to keep track of those alternatives than to keep track of the alternatives of filling the chairs. So suppose we start with all the chairs occupied. The first event has two alternatives. Either end can vacate. After that, the next event has two alternatives. Either end person can evacuate. And after that, again, two alternatives, either end person can evacuate. This will happen for 11 events. Then there will be only one person left, and that will be just one alternative. That person will vacate, leaving the chairs entirely empty. So we have 11 events of two choices each, followed by the last event, the 12th event, of just one choice. So we can get the number of ways of doing it by multiplying 2 to the 11th power. And I will do that keeping track of the powers in this way. I will start with 2 and double each time. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. That is 2 to the 11th power. So, since there are 2048 ways of going from full to empty, there must be 2048 ways of going from empty to full under the conditions of this problem. And so that's the answer, 2048. So that's my solution to my Please Be Seated challenge. I invite you to visit my profile page, find the math videos playlist, and browse. I have many interesting math challenges there. Thank you for watching this video.